Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Wong. Today, I'm with a special guest, Barr. Could you introduce yourself?
Yeah, great to meet you and good to be on here today. My name is Barr Moses. I'm the CEO and co-founder of Monte Carlo. Monte Carlo created the data and AI observability category. Fortunate to work with amazing companies like Nasdaq, Roche, Honeywell, Cisco, Fox, and many other organizations, helping their teams build and deliver reliable data and AI products.
So, I'm interested in your point of view on the concept of data observability. So, what is it? And then, I guess, what did companies used to do in the past with data observability?
Yeah, great question. I'll start by talking a little bit about the history of software and product development. Software and product development has been around for, call it like the last 30 or so years. And there's been a whole methodology and process around how to build reliable software products, reliable, secure, scalable. And a lot goes into that. In fact, DevOps has been a whole sort of industry to help support engineers in how to build reliable and secure products. And that's a very well known and understood process. And there are a lot of sort of players, a lot of companies in that space that help engineers do that. And some of the common names that you might have heard of are companies like Datadog or New Relic, AppDynamics at the time, Splunk. And what these solutions do is they help software engineers build reliable products. What has happened in the last sort of, call it 10 to 15 years, data is becoming an important part of building software. In fact, it's powering not only business critical initiatives and decisions in organizations, but it's also powering software products itself. And you used to say software is eating the world. Then we said data is eating the world. Now we're saying AI is eating the world. And I think for data teams, what do I mean by data teams? These are data scientists, data analysts, data engineers, machine learning engineers. There's a lot of people working with data today. And they are building a variety of data products. But what do I mean by data products? That could be a report that your marketing team is looking at to evaluate a particular marketing campaign that they're using. It could be a particular pricing algorithm that's helping to define the cost of a flight that an airline company is publishing on their website. And it could be a generative AI product, like an answer that a chatbot is providing to a user. In all of these instances, the data teams are responsible to make sure that the data that they are delivering to those products is accurate. And the ironic thing is that more often than not, the data that's powering all these products is inaccurate. I'll talk a little bit about why later, but the crux of the problem is that we do not have sufficient ways to ensure that the data that we're using is trusted, accurate, and reliable. And why is that the case? Because historically, if you're talking about the past, 15, 20 years ago, very few companies actually use data. And maybe 10 years ago, people use data, but very sporadically for a very small use case. For the most prominent use case 10 years ago was you had all of your data in Oracle or SAP, and once a quarter, you counted how many customers you have and how much revenue you have, and you reported to the street on that. And so you had the whole quarter to make sure that the numbers that you're reporting on are accurate. And by the way, those weren't always accurate in any case, but you had a lot of time and a lot of people to do that in a very manual way. And so historically, what people did was, first of all, they tried to start using data. And that has become a lot easier in the most recent years with the rise of cloud native technology. And so companies you're seeing really have a lot of momentum around that are companies like obviously AWS, Google, GCP, Bricks, Snowflake. All those companies have really become massive companies in the last couple of years with the advent of cloud, which makes the use of data a lot more accessible to way more people within an organization. And so what we're seeing in the last 5 to 10 years, all of these trends converging. First of all, it's a lot cheaper, easier, more accessible to use data. Two, we're using data of different types of different sources. So an organization will use a lot more kinds of data, structured data, unstructured data, data that's first party or third party. And the third is data is powering a lot more use cases. So again, in the past, if data was used just to report numbers to the street or just for internal reporting, today almost everything that we do in an organization is based on data. And if you think about the future, it's going to get only worse. But looking back, that's been the main trend. And what data and AI observability refers to is the ability to know that the data and AI products you're delivering are based on trusted and accurate and reliable data. The consequences of not doing that are a lot worse today than they were 5 to 10 years ago. So 5, 10 years ago, if your data was inaccurate, worst case, you reported the wrong numbers to the street. Today, the implications of that are way worse. That's really what had happened in the last 5 to 10 years. I think there's some notable milestones along the way that charted that path. Thinking about so around 2018, 2019, there's two large acquisitions, acquisition of Tableau by Salesforce and the acquisition of Looker by Google, two data companies that were acquired at the time, has signaled the start of the importance of data, the age of data, if you will. Fast forward a couple of years later, Snowflake is a company that went public that was actually the largest software IPO of all times. And the fact that it was a data company that was the largest software IPO at all times, I think is very meaningful. And then since then, obviously with generative AI in the last couple of years, I think that's really putting that on steroids, if you will, making AI and data a reality for every single company in every single industry.
I noticed that with the advent of AI, a lot of companies are taking their data, which is not cleaned up or pretty, and they're just throwing it at an AI system and hoping that they're gonna get some ROI from that, which obviously it's a bad idea to do, but that that's currently what a lot of companies are doing, at least what I've seen. From your point of view, what are like the challenges that you see these organizations like in regards to to using their first party data with AI, and more specifically taking like their first party data which is not cleaned up and not pretty, and trying to throw it into an AI system to get ROI, like what are like obviously I know this, but from your point of view, what do you think the big like pain points and challenges are?
Yeah, look, let's talk about the complicated reality that chief data officers, heads of data, CTOs are under pressure today, right? We actually did a survey of a couple hundred of data leaders and asked them a number of questions, and I'll share a little bit of the results. The first question was, how many of you or do you use AI today or in production? Or do you have an AI initiative? 100% of responses were a resounding yes. There wasn't a single person in the survey who would admit to not using AI today. 100% of them also indicated that they are under pressure to build with AI and to deliver with AI. The third question that we asked was, do you trust the data that's powering your AI? Only 1 out of 3 people actually trust the data that's powering that or feel confident that their data is AI ready. And that is a staggering reality because, on the one hand, there's a lot of pressure to build with AI and to deliver AI products. On the other hand, the data that's powering those products is inaccurate. And so I think for data leaders who are in that, live that reality, there's urgency to really get their data AI ready. And there's various ways to do that. I'll talk about that in a second, but there's real pressure to do that. Before I do that, I'll just share a couple of, for folks who are not aware, I'll just share a couple of examples of what happens when the data is wrong. The example that I like to give that I think I appreciate the most is went viral on X a couple of months ago. Someone basically Googled, what should I do when cheese is slipping off my pizza? And Google responded, well, you should just use organic super glue. Now, that funny, right? Okay, Google gave a terrible answer. And I think Google can probably get away with an answer like that because of the power of their brand. But 99% of companies out there cannot get away with giving such a wrong answer to a question. Worse than that, there's not just brand implications, there's revenue implications. So I'll give a couple more examples. About 5 years ago, Unity is a gaming company. They had a problem, and actually, this was a schema change, so changing the structure of the data that led to a loss of $100 million. Their stock dropped by 37% the day after because of one data issue. Several years later, Citibank got hit with a fine of $400 million for bad data quality practices. That's before AI. Fast forward to today, just this year, numerous blunders and instances with AI. For example, Chevy Tahoe was using an AI chatbot to sell cars. one of the users actually convinced the chatbot to sell the car for $1. Now, I commend that user to be able to fool the chatbot into doing this, but when you think about the revenue, regulatory risk, compliance, brand reputation risk, those are real for chief data officers and for CTOs. And so I think the dynamics today for organizations are tricky, right? That's on the one hand, that there's a lot of pressure to deliver. Here's the other interesting dynamic that's happening at the same time in parallel. In the last couple of years, there's been a lot of discussion on the latest and greatest foundational model, right? And we're noticing this or witnessing this great sort of battle of the giants, right? Between OpenAI and Anthropic, and there's a question of open source versus closed source, right? With Meta's Llama, et cetera. And for data leaders, the interesting thing is any data leader can get access to any of those models within just a couple of seconds or a couple of minutes. You can get an API key and you're all set. And so, interestingly, while there's this battle that's happening, there's actually a commoditization of those models because anyone can get access to the latest and greatest. And in that world, what is the competitive advantage for an enterprise? If I'm a bank or an airline or a financial advising company, how do I differentiate myself from all others? How do I create an advantage if everyone has access to the latest and greatest model? And what we're finding is that enterprises are realizing that really your moat in this case is your data, your enterprise data. And so my ability to create a way better experience for you with AI is if I have data about you that can help me personalize my approach to you, tailor my recommendation for you. If I have more information about you that is more specific to your needs and wants and requirements, I can actually differentiate myself. And so what organizations are learning is that actually investing and having really strong first party data about your customers, about your users is becoming the most important competitive advantage in today's AI world.
Yeah, I'd say the in order to really separate yourself from it, I do agree. Like having that first party data is extremely important. I feel as if a lot of companies don't realize that they're sitting on a mountain of data that's like extremely valuable. So like how do you like find companies that have this mountain of data that they're sitting on that they don't realize it's like just a pile of gold that they could take and build something very powerful with it? I feel as if a lot of companies still haven't realized that they're sitting on gold. What's your point of view on that?
Look, I think the trend for the last 5 to 10 years has been largely to hoard data, especially for enterprises. It's like the more the merrier. There's been that notion. And so what I encounter is way more enterprises that have a ton of data, are not even aware of the data, can't speak to which data should be used, which data shouldn't be used, not always aware of which data is being used and by who. And so, what I see as a core challenge is actually understanding the data that you have and understanding how to use it. A lot of business initiatives right now are around breaking down silos. And so bringing together, if I'm a media company, bringing together subscriber data, together with ads data, together with behavioral data. Oftentimes, those are aggregated in various places and actually bringing them together into one place so that I can make the cross-reference connections and build better tailored products. Personalization is a big initiative. And so I would say more than lack of data, I think there is sufficient. I think there is plenty of data. I think the bigger challenges is around understanding where this data lives and some of the foundational work around what should be used, what shouldn't, what can be trust, what can't. A lot of companies start thinking about gold, bronze layers of data and starting to have sort of the governance around that data. I see a big push around that, more so than collecting more and more data. I think in the last sort of call it 5 to 7 years, companies have invested in aggregating more and more data, and those that haven't are in big trouble. So, more than anything, I think it's about organizing the foundations for those data, for that data.
Yeah, I'm curious, like, which industries do you think might face challenges with their data quality as they're trying to implement these like AI solutions, more specifically like Gen AI? Like, what's your point of view on that?
I mean, honestly, my answer is that this problem is industry agnostic. Literally every industry that's using data will have this issue. I'll just give you some examples. If we think about, let's take airline industries, right? Airlines use data like flight number and what's your connecting flight and where's your luggage. That data needs to be highly accurate. Financial companies, they use that to do risk assessments, credit, mortgage. That needs to be based on highly accurate data. Same for media, content personalization. Really, every single industry that you look at, if the data matters, if you're using it for some business critical initiative or some product that a user touches and interacts with, you're not prone to error. So I don't think that this is something that's particular to any industry. I think it's cross industry. Obviously, there are industries that are highly regulated. So specifically financial services, healthcare, in those organizations, obviously the compliance and the regulatory financials are a lot stricter. And so those organizations are typically more mature or have more resources dedicated to that. But by and large, it's actually interesting. I would say I really do see across all industries this shared problem. We've also done some work to map what we think are the shared root causes for why data can break, sort of have some framework to help data organizations understand what are the main reasons for why data can go wrong. But that is actually industry agnostic. So, specifically, what I mean by that is if you look at any data issue for any industry that I mentioned, the first thing that's important to understand is how the data and AI estate has changed. We talked about how 5, 10 years ago, this was really just a Oracle or SAP instance. You threw all your data into that, or maybe you just track data in Excel sheets. Today, the data and AI estate has grown tremendously since. So it's not uncommon to have sort of a data and AI platform team, data and AI governance team, and you'll probably have a data lake or data warehouse, ETL, AI, agent, vector database. There's sort of a lot. The data and AI estate has expanded materially. Data can go wrong and things can go wrong throughout that estate. However, what we found is that what makes data and AI products unreliable can be traced down to four core root causes, if you will. The first is a problem with the data itself. So if you're just ingesting the wrong data, or maybe the data didn't even arrive. The second root cause could be the code. So the code can be wrong. But what I mean by code is this could be code that's transforming your data, or it could be code that's being used to actually build an agent, for example. Any change in that code can cause a problem in the data downstream. The third root cause would be a system problem. And by system, really the infrastructure that's running all these pipelines. 100% of systems fail. And so there's 100% confidence that there will be an issue with the system at some point. And then the fourth root cause is the model output. And what I mean by that is, you can have the perfect prompt, the perfect context, and still have a model output that's not fit for purpose, right? So using that Google example, the prompt was fine, the context was fine, but the response was still ridiculous to suggest organic super glue to glue your pizza back together, right? And classic example of model output that's wrong is a hallucination. Hallucinations happen. And for organizations thinking about how do we build reliable generative AI products, you have to think about each of those four root causes and actually have visibility in each of those four root causes across your data and AI estate. And that's true for any industry and for any stack that you're using for that matter.
I was about to say like the another like example of when AI goes awry is, I mean, it's a really silly example, but if you go on Amazon, you get to see a lot more AI written literature that's popping up. And one of them is like a guide on how to like pick mushrooms written by AI, which is probably like the worst book that you could possibly write with AI because I mean, you can get yourself killed if you eat the wrong mushroom. And I, for one, would not trust that type of writing from an AI. But that was like the first thing I thought of was like, I did see this book and I was like, man, this is a really bad book to have. And
Yeah, not sure if that would be my first pick for any literature, but sure.
yeah, and another like example that I thought of was I think it was like Air Canada that got hit with a lawsuit. So they
Yep.
they had a chat bot that gave out this like non-existent like discount or refund or something like that. And the customer went to the Canadian tribunal, and the tribunal favored with the customer. So that was really bad press for Air Canada. Plus, on top of it, they had to pay the legal fees. So that was like another example of when data goes awry that we should probably educate the listeners. So you really don't want to like put all your hopes and dreams into an AI system. That there has to be a human in the loop that checks the system's output. I'm curious just to hear if I take like a data infrastructure and I were to like evaluate the health on that infrastructure, like what are some metrics that you would suggest like an organization use to track that health evaluation?
Yeah, great question. And I think that's by and large what sort of observability as a definition is, right? Observability is assessing the health of a system by looking at its outputs. And that could be any system. It could be a factory that's producing cars, it could be a software product, it could be a generative AI application. In all of these instances, you're looking at the outputs to assess the system, the health of the system. Specifically, you talked about human in the loop. Still very much see that's the case in generative AI, and I don't expect that to change dramatically. I was just talking with Fortune 500 head of AI, asking him, how are you evaluating the output of your generative AI applications today? What do you look at? And he told me that they largely have users sift through hundreds of responses daily to check for accuracy. And it's mind blowing that what worked for us 5, 10 years ago, where people would manually look through the results of the quarter to make sure that those numbers are true, is still our method of choice to validate the output by having a user manually look through it. So I think to a certain degree, that's not going away, or it'll take time to automate that. Some of the things that folks look at to understand the health is the number of incidents that you have. So you mentioned this Air Canada example. I think it's a great example. And I think the just literally the number of incidents that happened, the time to detection for those instances. So there's a very big difference if the data and technology team identify that problem or if it's a user that identify that problem. I don't mean this to say don't build generative AI products. I want to make sure no mistake. I don't think waiting and sitting for the perfect data set is a reality that anyone can afford to do right now. I definitely don't think that's the case. I think we have to learn to live in a world where data is not perfect and we are still building generative AI products with it. However, ensuring a human in the loop, introducing automation where is possible. One of the things that I think are really interesting is actually how can AI help us make sure that AI is reliable? I'll give you an example. One of the things that folks used to do or is very important is to be able to specify rules for the data. To say, I expect, let's say I'm scoring, let's take a specific example. Let's take an insurance company that cares a lot about their support conversations. And they look very carefully at their support conversations. It's a combination of a number from 0 to 10, where a user is rating the level of support that they got, as well as a text, the conversation itself. The values of that conversation have to be between 0 and 10. A user cannot give a -5 or a 15 as a score for a support conversation, right? And so you can automatically ensure that the values are always between 0 to 10. What you can also start to do is to start evaluate the sort of semantics of the conversation itself as well. So did the conversation go well or not? Is it a positive conversation? Is it a negative conversation? And have an LLM actually structure data that's unstructured. So the unstructured data is a conversation. You could structure that by giving that a score, for example. And so these are just some of the techniques that folks are starting to start thinking about how to define what good looks like in the space. So that's one example. So how can we use AI to make detection of incidents easier? If you could basically, or one of the things that you could do is basically use AI to profile data and to make suggestions for users what kind of monitors or rules they want to put in place to ensure that the data is accurate. So I'll just give you an example. Let's say Again, let's go back to an airline example, and we have the weight of a suitcase, the weight of luggage. The weight of luggage, you could have the AI suggest that field has to be between, let's say, 0 and 100 pounds or whatever it is. If it was 20,000 pounds, that would be very surprising. Something is weird, right? And so, as an example, instead of making a user manually write all those rules and monitors to make sure that the data is accurate, you can use AI to profile the data and to suggest monitors that would help make sure that the data that you're using is accurate. So that's one neat example of how generative AI can help make the reliability of data easier. Another example of how you can use AI to make this easier is to actually accelerate troubleshooting of data and AI incidents. So something that data and AI teams spend a lot of time on is once there's an issue, actually understanding what's the root cause of it. So I bet the Air Canada data team was spending a lot of time understanding what went wrong with that chatbot, right? That created that user experience. And what ends up typically happening is there's a data analyst that comes up with a set of hypotheses for what can go wrong. And I talked about the four root causes. They probably start asking themselves which of those four root causes contributing to the data issue. Maybe there was a data source that sent the wrong data. Maybe there was a code change. Maybe there's a pull request, a GitHub pull request that an engineer did at that time that's related to this. Maybe there was an airflow job that failed, a system issue that happened. And basically, what the analyst does is for every hypothesis, they start researching that and starts looking at this hypothesis, try to understand whether it's correlated to this issue. That process by itself can take many days, weeks, sometimes months until you actually understand the problem. What we're seeing now is that you can actually use an LLM to basically an agent that spawns off agents for each hypothesis. So basically, you can run up to 100 or so agents in under 1 minute to investigate 100 or so hypotheses for why something went wrong. And the magical thing is you can actually do it recursively all the way upstream to the particular data asset where the root cause originated or where the issue initiated. And so a process that could take a human being easily weeks or months can now take just a couple of minutes by using LLMs. So I think the ability to accelerate troubleshooting, accelerate detection of issues, saves time, saves organizations and teams a lot of time and a lot of effort, actually frees them up to work on revenue generating activities, for example.
What are you guys cooking up at Monte Carlo? Can you tell us some cool stuff that you guys have been building?
Yeah, of course. Happy to share. I think there's a lot of things that are very interesting in the space. First of all, I talked about how can we use generative AI to make data quality easier. Obviously, at Monte Carlo, we spend a lot of time on that. And so we have a sort of suite of observability agents that we're going to be launching in the next couple of months. Some of them are already out in GA, some of them are in beta testing. The early results are quite astounding, I will say, in terms of reviews from users and the excitement for our ability to make an impact on organizations. So really excited about that. We're going to have a monitoring agent, a troubleshooting agent. Again, some of that is already live. Very excited about that. The second big part that I'm really excited about is actually expanding observability for the broader AI estate. I think more and more data teams, now that they have AI in production, we talked about the implications of that, of AI going rogue or going awry. And more data and AI teams are looking for ways to ensure the reliability of that. And so Monte Carlo is excited to pioneer that category. We've pioneered with our customers the category of data observability, and we're excited to extend that to data and AI as well. I'm really excited about that.
And for our viewers at home who are might be interested in learning more about this, what's the best way to contact you?
Feel free to reach out to me. I'm on LinkedIn. My name is Barr Moses. You can also email me directly if you like, bmoses@montecarlodata.com.
And then just looking forward, like how do you see the relationship between proprietary data and AI models like developing, especially with the traction that we're seeing with how Gen AI is evolving so rapidly?
Yeah, we talked about the models becoming better and better by the day. I think the role of synthetic data is critical in that regard as well. We're at peak data, if you will, which means we're going to have to turn to synthetic data and other options in order to continue to make the models even better. And definitely think that's going to continue to be an exciting space to watch. And I think for enterprises who are looking to have an advantage and build really powerful generative AI products, they need proprietary data to make that great. I think that's really actually the chief data and analytics officer of JP Morgan Chase just gave an interview a couple of weeks ago in a Wall Street Journal. And her quote was something like, our models are very important, but they're not our secret sauce. Our secret sauce is actually the information that's powering those models. And that's actually how we create value. And I think that's a really powerful quote because at the end of the day, your generative AI product is only as good as the data that powers it.
Thanks so much for being on the show. And until next time, stay curious.